Hello dear fans. Archimedean force, what does it mean? The Archimedean force arises from the fact that a liquid or gas strives to take back the place taken from them by a submerged body, and therefore pushes it out. The force of Archimedes acts only in the presence of gravity and has different meanings on different celestial bodies. This force acts not only in liquids, but also in gases. Balloons and airships float in the air like a submarine underwater. The cause of the emergence of the Archimedean force is the pressure difference of the medium at different depths. Therefore, the force of Archimedes arises only in the presence of gravity. On the Moon it will be 6 times less, and on Mars 2.5 times less than on Earth. In zero gravity, there is no Archimedean force. If we imagine that the force of gravity on Earth suddenly disappeared, then all ships in the seas, oceans, and rivers will go to any depth from the slightest shock. But the surface tension of the water, which does not depend on the force of gravity, will not allow them to rise up, so they will not be able to take off, everyone will drown. How the power of Archimedes manifests itself. The magnitude of the Archimedean force depends on the volume of the submerged body and the density of the medium in which it is located. Its exact formulation in the modern concept, a buoyant force acts on a body immersed in a liquid or gaseous medium in a gravity field, exactly equal to the weight of the medium displaced by the body, that is, F equals rho GV, where F is the Archimedes force, rho is the density of the medium, G is the acceleration of gravity, V is the volume of the liquid, gas, displaced by the body or submerged by it. If in fresh water a buoyant force of 1 kg, 9.81 N, acts per liter of volume of a submerged body, then in seawater, the density of which is 1.025 kg cubic meters. dm, for the same liter of volume, the force of Archimedes will act in 1 kg, 25 g. For a person of average build, the difference in the strength of support from sea and fresh water will be almost 1.9 kilograms. Therefore, swimming in the sea is easier. Imagine that you need to swim at least a pond without the current with a 2-kilogram dumbbell in your belt. The Archimedean force does not depend on the shape of the submerged body. Take an iron cylinder, measure the force of its pushing out of the water. Then roll the cylinder into a sheet, submerge it flat and edge to edge in the water. In all 3 cases, the strength of Archimedes will be the same. At first glance, it is strange, but if the sheet is immersed flat, then the decrease in the pressure difference for a thin sheet is compensated by an increase in its area perpendicular to the water surface. And when immersed with an edge, on the contrary, the small area of the edge is compensated for by the higher sheet height. If the water is very strongly saturated with salts, which is why its density has become higher than the density of the human body, then a person who does not know how to swim will not drown in it. In the Dead Sea in Israel, for example, tourists can lie on the water for hours without moving. True, it is still impossible to walk on it. The support area turns out to be small. The person falls into the water up to his throat until the weight of the submerged part of the body is equal to the weight of the water displaced by him. However, if you have a certain amount of imagination, you can add up the legend of walking on water. But in kerosene, the density of which is only 0.815 kilograms cubic meters, dm, will not be able to stay on the surface, and a very experienced swimmer. Archimedean force in dynamics. Everyone knows that ships sail, thanks to the power of Archimedes. But fishermen know that the Archimedean force can be used in dynamics. If a large and strong fish, taimen, for example, is caught on the hook, then there is no point in slowly pulling it to the net. Pulling out, it will cut off the line and leave. You must first tug lightly when she leaves. Feeling the hook at the same time, the fish, trying to free itself from it, rushes towards the fisherman. Then you need to pull very hard and sharply so that the line does not have time to break. In water, the body of a fish weighs almost nothing, but its mass is preserved with inertia. With this method of fishing, the Archimedean force will, as it were, kick the fish in the tail, and the prey itself will flop at the feet of the fisherman or into his boat. Archimedean force in the air. The Archimedean force acts not only in liquids, but also in gases. Thanks to her, balloons and airships, zeppelins, fly. 1 cubic meter m of air under normal conditions, 20 degrees Celsius at sea level, weighs 1.29 kilograms, and 1 kilogram of helium 0.21 kilograms. That is, 1 cubic meter of the shell filled with helium is capable of lifting a load of 1.08 kilograms. If the shell is 10 m in diameter, then its volume will be 523 cubic meters. Having made it from a light synthetic material, we get a lifting force of about half a ton. Aeronauts call Archimedean force in the air floating force. If you pump out the air from the balloon without letting it wrinkle, then each cubic meter of it will pull up all 1.29 kilograms. An increase of more than 20% in lift is technically very tempting, but helium is expensive and hydrogen is explosive. Therefore, projects of vacuum airships are born from time to time. But modern technology is not yet capable of creating materials capable of withstanding a large, about 1 kilogram per square cm atmospheric pressure outside the shell. Thanks for watching.